Hello, Mark Surgeon again, and following the material basics tutorial. To add even more realism to this reflective materials, we can add something as an environment map. So now this will be a bitmap, and I will use an environment map. I just downloaded it from the web and open it up. And by default, because it's an environment map, it's mounted as a wrap. So what does that mean? If I'm opening up Material Editor and drag and drop it onto a scene and instance, this is our choice, it will automatically switch to environment map. Mapping mode is spherical environment, so this map is actually stretched in the virtual sphere that rounds this whole set. So, and I will click on render preview and make it update, and as you see, the whole set, the whole scene will look a little bit different because the reflection will be updating. Now, to make it a little bit more exciting, I will turn on region render and we'll render just this part of this item and hit on render, and let me see the difference. Now, the more environmental information you have, the more visual details can you show on a reflective material. So material and environment are going in hand. So if you have a virtual environment that shows details, those details will catch up on the material representation. Alright, now I will leave it as it is, and it is time to move on and create a displacement like material. So, but for that I will reorganize this scene a little bit, and also want to improve quality. So now I don't need that much previews. I will close this up because environment setting is already done, and I guess we need more distance and move away some of the guys, probably make it closer. Okay, and make a copy, okay, from this one. Right, just looking for some kind of a composition. I don't want to make it that ugly. Perhaps it's more exciting if we see some quality here and there. Alright, now this will be a displacement material, and as it is, I will keep it quite close to the camera, move this way a little bit up, and create a new material, and that material will be a masonry material. But that masonry material is accessible from physical materials, so double click on physical, and from the presets I will pick a masonry. So here's a masonry. We have so many, it's a good idea to test them out, and as you see, we instantly have a texture, so it's visible, it's included in the material, so it comes with the installation. Many things are set. We have a prepared displacement map, so it's all fun to work with. As you see, we have reflection color mapped, base color mapped, so we don't have to really spend too much time with it. Okay, now I will hit on Shift Q to test render it out. And yes, we have the shadows. This is pretty nice. The rendering quality is not that good, so I will increase the rendering quality. Rendering time was 11 seconds now, so we can still easily increase it. F10 is the hotkey for the render panel, and the art render is set to draft. I will crank it up to somewhere around medium, slightly below medium, and I will enable the filtering, and that will be a slight filter, not much. We're still in the testing phase. I just wanted some reasonably a little bit better quality rendering, okay, but still a reasonable amount of time. So the previous render was 11 seconds. Now it is at least half minutes, and iteration numbers are going up, so it calculates, but as you see, it's already much cleaner than the previous one, and the rendering will be about 1 minute overall, so it's not that bad at all. Okay, let me have it. Yeah, it says 41 second, not really true, but we are here. So as you see, the comparison, there's a huge difference between the two. Reflection quality, shadow quality, highlights, everything. This is much better result. Okay, now I will keep it as it is, and here comes the trick. I'm interested in using the displacement. So this material has a displacement channel. Displacement channel is already loaded with the masonry brick modular bump JPEG. So I will just turn this on and look at the results. Now, just quickly, before we are actually rendering this, so double click on it and waiting for the material sample, and as you see, something happened. It's not really there, but something happened as I just turned on displacement. These jagged edges appeared. Now, what we have here, we have a low resolution 3D sphere, and it tries to displace this low resolution sphere. So it tries to mimic the thickness of the geometry of the bricks here, but it's not that accurate. Try to make the render. I hope it can make something. So Shift Q. So let me see. Oh, yeah, there is a problem. There is nothing changed here. So I want to calculate the whole image. Click on cancel or hit escape. So it's not really funny. It's not what we want. What we want is something with more accurate displacement, or at least visible displacement, because it's barely visible here. Now to manage that, to handle that, we will select the model, pressing F4 to check the geometry we have. And what if we are using a turbo smooth? Because turbo smooth is a subdivision type of modifier, and once you have subdivision, there's a chance you can use the subdivision, already subdivided geometry, to create the displacement while you are rendering the item. So I will hit on F9 to render the previous, and here we go. The displacement takes effect. So as we see, there is a visible displacement. It's not really what we are looking for, but at least we can recognize that we have displacement. Now the problem with this one is displacement is usually working with subdivision modifiers or subdivision with multiple polygons. So the more polygon you have, usually it's easier to create accurate subdivision. So we can avoid this method using the turbo smooth and can get a better results by converting our item into a polygonal model. So turbo smooth, delete the modifier. I will convert it, not just using an editable modifier. I will entirely convert it into an editable poly. And within the editable poly, we have subdivision displacement, a separated rollout, and nothing else. I will do just one thing. I will turn on subdivision displacement, and using the same trick, F9, to render the last item. And I was zooming in, and here we had these jagged edges, and now it's much more nicer. Okay, so the displacement is quite visible. Probably it's better if I slightly change the angle, and also I will switch to regular mode, and 2 steps, maybe 3 steps. Just let me check it. So Shift Q to render this, and yes, so it's much more accurate. It's way better. The visibility is way better. And as you see, the displacement is pretty accurate. Okay, so this is really nice and accurate here. Alright, now it is enough, so I can stop this by pressing on cancel, and we can move on to work on with another option to be presented. Alright, the option I'm looking for is self-illumination. So what I will do is I will just reorganize the models, and what I do need a tiny smaller model, and that will be reduced in size, and I will create a new material for that, and that will be a kind of a glow material. So the samples are switched here, and I will call it glow, and the material is actually a physical material, and the color will be reddish, and just put it on the material. So here, assign material to selection. That's nice, and let me render it quickly. So I'm just curious about the changes I made. Okay, now it's visible. It is a shiny material as it is. So I will cancel. It's right there. Position is right. Here we have the shadow. And what we can do is I will keep it as it is as a shiny material, but here we have emission. Now emission makes it funny, so I will add emission color matching to my original color, so that will be a reddish kind of an emission. Okay, preview takes some time to load, and emission amount is about 0.4. Okay, now make a test. So Shift Q, and voila, what we have a self-illuminated item, and this was looking pretty cool. Okay, so if you want to create special shaped lights, this kind of emissive materials are the best to achieve that. So it can make really a good option to deal with. Alright, now another thing, I'm not sure if it will work correctly, but let me check this. Here we have cancel. Here we have this green material, and that green is this matte surface. Now what I can do is I can use subsurface scattering. So here, this is the base color. I will copy this color, and in the subsurface scattering I will paste it. Now this one is a solid material, a solid sphere, and usually that's not really optimal for this type of a trick. So I will use a shell material, and shell, but the wall thickness will be relatively low. And to make it fun, I will go up in the perspective and create a free light, and the free light will be placed within the model, but relatively close to the center, and that will be shadows. We don't need shadows, but we need uniform diffuse. So it's a kind of a point light. Then this point light is distributing the light from top to bottom, so the light will concentrate here on this bottom part, and I will just enable subsurface scattering. That's way too much, and the scatter color will be kind of a yellowish. So when the light affects this material, that will be a little bit yellowish. So I will go back to the camera view and Shift Q to test it out, and let me see what we have. Okay, now it becomes a little bit more exciting. I guess that light is way too strong now, but as you see, the difference is it's not emitting light, it is it is it is lighting itself because I have a light inside that, and because of subsurface scattering, that's actually the light is distributed within the material, within the wall thickness, and this is why it becomes an illuminating object itself. Okay, so imagine this as a physical version of some kind of a, imagine you have a candlelight, and when you see the candlelight through the wax of the candle, this is the effect you get. Milk, soap, human skin is behaving the same way. Okay, so subsurface scattering is turned on. The scattering is usually matching in color, and the scatter color is somewhere near to this one. So if you have a pink skin, the scatter color could be reddish. If you have milk, it could be kind of a grayish tone, or reddish, depending on the environmental light. Okay, now I will select the light and reduce the intensity because this is way too much, so I will reduce it to 500 and quickly check this. Okay, I'm pretty much curious how it changes. Okay, we still have this subtle effect of this glowing item. Probably it could be even lower, so even 3 by half, so 250. Just let me see it. Okay, it's a nice effect. So the light is just distributed inside the material and bouncing back and forth. Okay, now a couple things. We have first of all, we have depth of field in the camera, so we can sense that depth sense. We can create that effect. We also can add vignetting, for example. Now just let me show these before rendering it for ours, and I will also reduce it to 150 and just or simply 100. So I just want to make a subtle effect. Okay, that will be nice. Right, cancel, stop. And here we go with the rendering effects of depth of field. So camera is selected, select camera from here, this view. It's always easy to select a camera, just click on the left mouse button. And now it is selected, and closing the material editor, and this will be the left view. And what we have is we have these lens value, and we have aperture, that's 8. We have also enabled depth of field. Now, depth of field is actually using the target distance. So the target distance, as you see, is indicated here. Now, if you want to sharpen the area or change it, you can easily change it by dragging this distance spinner. So that's one easy way to adjust the depth. Now I will keep it on the glass material and moving to the aperture. Now aperture is actually, if you increase aperture, there will be a wider range of sharpness, but if you're reducing the aperture, the blurred effect will be stronger on the materials in the background and foreground. Now by default it's 8. In this case we want to make it quite low, so it's 5 to make it visible, and also I want to enable vignetting, but right now it's enough if we are just dealing with the I don't know, let's turn on vignetting. Here's the preview. Okay, we have a couple iterations, and yeah, that's everything is visible, and the vignetting amount is maybe, oh, it's too much. I will use it. Okay, just let me, here I'm checking this value. Okay, Now 8 is fine. And we also have depth of field turned on, so Shift Q. And let me see it. Depth of field is working, so these edges are blurred. These are a little bit out of focus. And also these edges around here, these are also a little bit out of focus. So that's coming along nicely. My only problem is the rendering time, because I have a couple materials, not much, but because of the lights, because of the emission effects, because of the self-illumination, the displacement and everything, the rendering is usually slows down. So it's a good idea to keep it as low as possible, and keep the resolution reasonable amount. Now, okay, I'm curious about the overall rendering time, but as a guess, it will be somewhere about 2 minutes. And to make it effective and work effectively with these kind of renders, we can optimize rendering time. Especially important if you are going with an animation, so or if you want to create multiple frames, because somehow you have to control the quality and you also have to control the time at the same situation. Now it's you have two options. One option is by limiting the number of iterations, or limiting the time amount. Now time amount is good if you want to make sure that your animation is calculated for the same amount of time each frame. So when you're using this, you can get a quite reliable preview in your estimated time, but the quality will be a huge variable, because even if you have a huge scene with hundreds of elements, the computer will spend the same amount of time for every item, for every frame. So if you have mountains, houses, full cities, it will still spend the same amount. Now, how to adjust it? This was 2 minutes and 2 seconds, so I was just recognize that and remember that. What we can do, we have a stop rendering even if quality is not attained at a time solution. So instead of using 2 minutes, I can tell 1 minute, and from now on every frame will try to goal to target this this 1 minute amount. Now the other thing is iterations. Iterations is a little bit different, because it will all the time create the same quality until uh, it will count the iterations. And if you have high variety, if you have different scenes, one after another, then it's better if you're using this iteration mode. Now I will use it at 100 iterations. Just let me check it. How the 100 iterations will do. Okay, so 3, 4. The previous was 2 minutes, and it's going on, and yeah, so that will be somewhere around a minute of a rendering time. So if you have a concrete time frame that you want to fit in, use time. If you want a target quality, if you want to reach the same quality for every frame, then you better with the iterations. You have to test the optimal iterations. You have to test a high density image with a lot of models, and because there's a chance it's not the same in iterations and time, so it cares some it requires some planning, but otherwise it's both methods are just great to optimize rendering time and get some quite reasonable quality. Okay, so 100 iterations are almost equal to the 1 minute setting, and both of these are cut the previous render time in half, but kept a reasonable good quality. So thank you very much. This was the overview of materials and rendering with the art renderer, and thank you. See you next time.